Hello guys and welcome back. In this session, we'll see how to build our own APIs using the FastAPI framework in Python language. Previously, we had seen that we could wrap our deep learning model, or more precisely our object detection model, into an API and then let these clients consume this API. That is, allow them send requests like this and then get responses. So here in black we have the requests, and then now we have the responses in red, and all this is done using the HTTP protocol. Don't forget to subscribe and hit that notification button so you never miss amazing content like this. And so now that we understand the concept of an API and how this can interact with millions of clients everywhere in the world, we are going to move straight to building our own API. And to build our own API, we are going to make use of this Python framework known as FastAPI. Now, other Python-based frameworks which can be used in building APIs are Django and Flask. But in the recent years, the FastAPI framework has gained much popularity amongst Python developers thanks to the fact that it comes with some key features like its speed, so it's a high performant framework. Time taken to code is reduced. That's now developers could now build features even faster. With FastAPI, you even have fewer bugs. It's more intuitive, it's easy, it's kind of short, robust, and is standards based. So because we need all these features while building our object detection API, we kind of have little or no choice but to turn to the FastAPI framework. And you're gonna see how easy it is to create or build a fast, highly performant and robust API very easily using the FastAPI framework. First things first, feel free to check out this documentation at fastapi.triangulo.com. Working with the FastAPI documentation doesn't really feel like a usual documentation, as most of the concepts are well explained and broken down to enable just anybody with minimal Python knowledge understand and use FastAPI efficiently. So right here we have the features, FastAPI people. You could get straight into this tutorial here, user guide. You see you have this well-written user guide. You also have the advanced guide. So once you're done with this user guide, you could get to the advanced user guide. You have special topics like concurrency, deployment, project generation, and all this. And so before we move on, don't forget to star the FastAPI GitHub repository. One of those course prerequisites is having used Python at a very basic level. And so we're supposing that you've already installed Python, without which you could head onto python.org, download and install Python based on your own operating system. So here you could see we have Python installed, Python version, check that out, 2.7. And then Python 3 version, we have 3.6. This should be 3.6. Okay, there's an error there. We have 3.6. Okay. Now the next step will be to install FastAPI. So we head back to the documentation. You have here this installation. All you need to do is pip install FastAPI, or you could do pip install FastAPI all, so you get other optional dependencies and features. We'll start by installing FastAPI. We have pip3 install FastAPI. There we go. API now installed. We could do Python 3 and then you import FastAPI. You could check out the version right here. We have FastAPI and then we have the version. Okay, so that's it, 0.78.0. So the next problem we may face will be, what if we have this project, this object detection project, in which we have the FastAPI version 0.73.0, for example, installed. Let's say 0.73.8 installed. You have this other project on optical character recognition which needs a different version of FastAPI, that is 0.75.0. You find that with this, there will be a conflict as what we've installed is this 0.78.0 version. Now, the way we could solve this is by making use of virtual environments. The way virtual environments work is you could have this project, this object detection YOLOX project, have its own isolated Python environment with its own interpreter where you can install these libraries in this Python environment without it affecting this other project, which is with another, or which is built in another virtual environment, where here we have a different set of libraries and library versions installed. So this means that in this environment here, we could install a version of NumPy, say, let's say whatever version, and then here again we could install another version of NumPy, which could even be the same as this version. But the difference now is in this virtual environment here, we have a version of FastAPI which is 070, 0780, and in this other virtual environment we have this other version which is 0750. And now this problem of conflict at the level of the dependencies is resolved. Now that we want to create Python virtual environments, we are going to make use of this Python module, which is the Python venv module. So here we'll simply do apt install the Python 3 venv, and that's it. So here, yes, okay, and that should be installed. Now we have the venv installed. Let's get into our neural learn projects directory, and then from here what we'll do is we are going to create our virtual environment. So we have Python 3, and then we have venv, and then we give the name to this virtual environment, which should be venv YOLOX, for example. So you could choose, you pick out whatever name you want. So you have that, you run that, and that should be fine. You see now when we do this, you have this venv YOLOX folder right here. Our next step will be to activate our virtual environment. So at this point, as we've seen, we have this folder, and we could actually get into this folder and see what it contains. So we have this venv YOLOX, ls, we have bin. Now let's get into this bin, get into that bin, and then again you see we have this activate right here. So now let's get back, and then we'll do source, then bin activate. So what you notice now is you have this venv YOLOX here before this root. So you see before we had just this, but now we have this, meaning that all what we'll be doing now will be in this virtual environment. In this virtual environment, if you do Python 3, you see we have that installed. Now if we do import FastAPI, see model not found. Now let's exit, and then let's deactivate. So that's how you get that's how you deactivate the virtual environment. So now we deactivate, you see we get back to this. Let's do Python 3, and let's import FastAPI, and you'd see that FastAPI here is installed. So in our virtual environment, FastAPI is yet to be installed. So let's get out of this, and then we get back and reactivate. That's it. And now we're set to do pip install FastAPI for this our virtual environment. You see that now we could make use of this FastAPI version for a particular project in this our virtual environment, and then create another virtual environment where we'll make use of a different version of FastAPI for that other project. So let's run this pip install, and everything should work fine. There we go. Now we do Python 3, we import our FastAPI, and that's it. You see this is now installed for virtual environment venv YOLOX. We do FastAPI, we could get the version. So here we have our version, and that's it. So let's exit and then move on to the next step. Now before we move on, we'll just install this FastAPI with all the other optional dependencies and features. So we could have this, and then we just simply paste this out here and run that. You'll get to see now with this pip freeze that we have many more dependencies installed because we decided to do that. So here you see we have typing extensions, starlets, Nifio, Pydantic, which is very useful, and these others. Now the next step will be to install UVcorn. And UVcorn is an ASGI server. So ASGI here signifies asynchronous server gateway interface. Being a HTTP server, this UVcorn right here is responsible for taking requests from different users. So supposing we have these 3 users right here, they want to get, for example, some predictions from a model which is here in our FastAPI, which we've bundled in this our FastAPI code. So what will go on here is this user, for example, will make a request, see, to this server, and then the server gets that request, interacts with FastAPI, obtains a response, and then sends back this response to this user. Now, if we want to connect with this web server locally, we could pass in this IP address here, which is that of the local host, and then we specify a specific port such that we now here, that's the client, sends the request which contains the method, which could be, for example, let's say a post method, and then the request body and headers, such that once this web server receives this, it processes the information and produces the required responses. We are now going to dive straight away into some practicals. So here you get this FastAPI, you have this simple tutorial here which we are going to follow and see how to easily work with FastAPI. Right here we have this which we are going to copy, and then we'll get back here. You see we have that, we do code, then we're going to open up VS Code. So you have that, you see in this Explorer we have our neural net projects folder, and we could create this new file. So here we have main.py, create this new file, and then we paste out that code. Now if you're working with VS Code, it's recommended to install this Python extension. So we just go ahead and install this extensions. See we have that installing. Let's get back to the code, or let's just get back to this. So here for example, let's enlarge this so it's clearer. Here for example, you see we told to create a file main.py, and with this code we are going to put in there. Now to keep things simple, we are going to comment this region and then also comment this right here. So we're not going to make use of this, we're going to comment that, and that should be fine. Okay, so we just have this portion or this part here. Now you see here we have this app which is an instance of FastAPI. See, we've imported this from FastAPI, and then we have this decorator here, and we have this read root method. Now this read root method, we could actually change this, so we could say read neural learn root, or whatever name you want to give it. So let's call that read neural learn, or let's just keep it short, let's just say read. So we have this read method, takes a nothing, and then it returns this dictionary or this JSON, hello for the key and world for the value. Now you could check out our course, our free essential Python programming course, where we treat topics like decorators. So getting back to the code, we have this decorator right here where we specify the method type. Recall we had different methods like the get, the post, put, the delete, and so on and so forth. So here for example we specify this method. So this is the get method, and so if we making use of this get method right here, we have this path here, we have this path, and then this means that if our web server is hosted on an address, for example, let's say https whatever.com, then this root path will correspond to this path right here. And then if we want to do, say, a login, then we have here login. This login path will correspond to having this login right here. Obviously, we'll have a post, so we'll change this to post, and that's basically how it works. You see how easy it is for us to create this kinds of paths with FastAPI and also specify the methods very easily. So here we have that, and we could have slash or let's say a, whatever we want to have there, and then all we need to do here is to have this here a. Now obviously we could have some variables here, and we're going to look at that shortly with this other example below. Anyways, we understand that if we want to get to an address here, whatever.com, or let's even say google.com. Let's say we're trying to build google.com, then we will just have here this, and that will be it. And so with this now, specifying this is going to get into this method and return this JSON. Now to run this, we'll just use what we've been given here in the documentation. Let's copy this out and simply paste this out here. So here we're going to open up the terminal. So open up this new terminal. There we go. Could clear. That's it. And we in neural net project. So make sure that you're in the same folder as where your main.py is found. So you could make this in a different folder, but for now let's just assume that we're in the same folder, so that we have main, and then we now specify the app. So with that now we reload. So let's take this off. Let's not make use of this reload. So let's take this off here. That's fine. We run this. We told uvcorn command not found. So what we're gonna do now is simply to install our uvcorn. So we have uvcorn now, which is going to be installed. And now that we have this installed, you do pip freeze. You see, do that pip freeze. You should have now this uvcorn appear right here. So we have FastAPI and uvcorn now installed. Let's paste this out again. Take off the reload. We run that, and we told this has no attribute run. The problem is coming from this model async.io, which has no attribute run. Now let's search on this async.io. We told it's a library to write concurrent code using the async await syntax. So async.io is used as a foundation for multiple Python asynchronous frameworks like FastAPI, as we can see, that provide high performance network and web servers, database connection libraries, distributed task queues, and so on and so forth. So now we get in this error. What we'll do is we're going to copy this and try to search this on Stack Overflow. So let's simply paste this out, and we see what we get. Okay, this error is kind of recurrent, so it's here, and we get this solution. Async.io, let's increase this. Async.io is a Python 3.7 addition. In 3.5, 3.6, for example, is roughly equivalent to this. So we told that this is a Python 3.7 addition. It means that from Python 3.7 onwards, we should normally not have this problem. Getting back here, when we do Python, we see that our default Python here is 3.6.9. So we try to get an idea of, we start getting an idea of why we get in this error. So let's get back, and then what we'll do is we're gonna create our virtual environment, but this time around with Python 3.8. So let's go ahead and install, or let's suppose we've already installed Python 3.8, and let's go ahead now and create this new virtual environment and launch it with Python 3.8. Now we have Python 3.8 venv YOLOX. Now we get in this other error, and this should be because our venv was installed with a different version of Python. So let's start by removing this Python 3 venv. Let's take that off, and then we're gonna reinstall our venv this time around with Python 3.8. Now we have apt install Python 3.8 venv. That should be fine. And now we do Python 3.8 venv and then venv YOLOX. So that's it. You see, it's been created. We deleted the previous one, so now we have this virtual environment which has been created and which we can now launch. So we just have source venv YOLOX bean activate, and there we go. We have this activated. Now let's get back to our code. Let's paste back what we had before. Let's clear this. We launched our server UVcorn main, because this is main.py, and then app. So we told this command is not found, and the reason why we have this is because UVcorn and FastAPI, or rather, let's start with UVcorn. UVcorn is not installed, that's why we have this. Even FastAPI, if we do Python in here, see the default is now 3.8, but if we do import FastAPI, you see model not found. So let's exit and then let's install this tool. There we go. We have FastAPI installed. That's it. And then from here we're gonna install the UVcorn. We now have this tool installed, so we could do UVcorn and we run that. Error loading ASG app attribute app not found in model main. So let's check this out. Let's save this and then run this again. There we go. See, now it works. We have started server process waiting for application startup complete, so we wait and then it's completed, and now UVcorn running on this address on our local host. So what we could do here is we simply control and we click open this. So control click and it opens up this page right here. There we go. The first thing we notice is this message where we have method not allowed. But why will we have this method not allowed message? The reason why we have this is because here, let's open this. The reason why we have this is because here in the code, we actually use this wrong method. See, we're supposed to use a get method instead. So we should change this and have this get. So let's save that again, and then we would stop this and then run that again. Click on this, open this up, and there we go. We have as we expected the JSON output. Here we have the ID, or the key hello, and the value world. Now another thing we could do is we could get back here. Let's stop this. See, we stop that, and then let's do let's say entry point. Let's have that, and we save this. So we save this, and then we run this again, and then we click on this, and you see detail not found. So here, because we do not have this path, it outputs not found. So let's do this. Let's say entry point and run that, and you should have an answer. Let's check this out. Here we have entry point, and then here we have entry point. Let's get back here, and then we should have this. To resolve this issue, we have to put the slash before the entry point. So you have to be very careful with the way you write this. Now you save that again, and then you reload. But aren't you tired of always having to reload? I guess as myself, you would also get tired of doing this. So let's do this. Instead of having that, we would add this reload here, such that once we save or do modifications and save here, automatically our server is reloaded. So now we'll run this. Application startup started. Let's click on that. We have this, and then we do entry point. That should be fine. So that's it. We have hello world as we expect. Now let's go ahead and update this. Let's just say entry. You see, when you save now, you see here, you see it's shutting down, waiting for application shutdown complete, finished server process, started server process, waiting for application startup, and application startup completed. So now we have this which has been reloaded. So unlike previously where we had to stop and then start again, now once we make the modifications, it's automatically reloaded. So let's get back here. Not here. Let's get back here. Oh, not here actually. Let's get back here, and then we are gonna have let's run this. You see, it doesn't work, but when we do entry, it works now, and we didn't have to stop the server for that. The next thing we'll look at is another interesting feature of FastAPI, which is the Swagger UI. So here we've saved this, reloaded our server, and then we get into this, and then instead of having that, we'll do docs. So you see we have docs. So we have this page which pops up, and you'll notice that we didn't need to specify that in our code. So let's get back here, and what we see is we have this method here, and then when we open this up, you see that's the path, and then we have the parameters there, no parameters, so we have this simple get request, and then we have the response. So here the code 200, and that's a successful response, and then the media type JSON, and that's it. So now let's go ahead and try this out. So you see when we try that, we click on try that out, and then this comes up, we click on execute, and what we have is this output right here. So here you could see the response body, and then you could have the response headers. So that's it. You could also repeat this on the Postman. So we have that, you see the request URL, and then you have the CURL. This you could use also to make the API calls. So that's it. We see how to make use of these docs, and now what we'll do is we are going to uncomment this two parts here. So here we uncomment this, and then we'll uncomment this part, and then we save this, and then you see here we have these items. Now we will notice that when we get back to our code and then we refresh this, we have this automatically put out here. So this means that no matter the number of different paths we create, we can automatically test them without any extra effort, thanks to this FastAPI's Swagger UI. So like here, for example, you not only can test, but you can also see the documentation. Like here we told that, oh, this is an item ID, it's an integer, it's required. Then this is a string cure, a query, it is optional because here you see it's not required. And then you could try this out. So let's go again and try that out. We you see, well, let's cancel, and then you see you cannot do anything here. Once you want to try out, you could put in an ID. So let's not put anything there, let's just execute. You see we must put out something. So let's have that 20 the string, let's leave that for now and execute. So what do we get as results is this output, item ID 20 cure null. Now if we modify the code right here, so let's modify the code, and then let's just say item ID, save that, we get back here, and then let's re-execute. Actually, let's re-execute. What do we get? You see it's automatically we have this modifications, and then now we could do this. Let's say hello, we execute that, and you see here we have our optional string, which has been shown to us in this JSON. So we had seen the JSON format already. Here we have the key, we have the value, the key, we have the value, and so on and so forth. And then also we have the response headers. Getting back to the documentation, you could see here, let's scroll back up. No, let's get down. You could open this up. You see the main, the file, the app, the object created inside of main.py with a line app equal FastAPI, reload, make the server restart after code changes, only do this for development. So they're saying that if you're in a production setting, that if you've deployed this, as we would see in the next sections where you want to deploy this, you don't want a situation where you get to have this reloads automatically. So from this now, you see basically explain what we've said already. Receives HTTP requests in this path and in this other path. So we've seen this already. Now both paths are get requests. So we have the get methods. The path, this path has a parameter item ID that should be an int. This other path has an optional string query cure. So that's it. And then here they get to talk about the Swagger UI, and then you also have this alternative doc API docs here, which is redoc. So basically what we'll do is we just get here, and then instead of having all this, let's say we have that, we just do redoc. We run that, and you have this alternative UI here where you could still again test this APIs. So that's it. You could test this very easily. You see, we have that, and then you should be able to test this. Now you have the response samples from here. So for this, you have this response sample. You have the either as a successful response or the response is unsuccessful, where we have this 422. Now you could check out in the Mozilla platform where you see the exact meaning of this 422. So let's check out developer Mozilla 422. So you could always get back to all this, so you don't have any issues understanding any code you receive as output. So here you see unprocessable entity. That's it. That's it for this here. We have different responses. That's fine. The next feature we'll be looking at will be that of schemas. What we'll do here is we'll simply take this off. We'll keep it simple. We will not use this, and then we'll change this into a post request. So we have this post request right here, which takes in a body. Obviously we have a body, and then it returns the elements in this body. Now here we'll take this off, and then we have our post request. So there we go, we have our post request. It's no more read item, but now add item. Now here we're gonna have an item which is gonna be of type item. So this is gonna be a special type we're gonna create. Now here we are gonna import pydantic, or from pydantic we're gonna import the base model. So that's what we're gonna do. We're gonna import this base model from pydantic, and then we're gonna create this item, this class item, which is gonna be a subclass of this base model class right here. So we have this item, and then we have base model. So that's it. And then here we're gonna say, okay, we want that an item should have a name and a price. So we have name, which is a string, and we have a price. Price, let's say integer. Let's say our price an integer. Okay, so that's it. So there we go. Well, what we're gonna receive here is this item of type item. It's no longer the usual types, but now this special type item which we've just created. So now here we have item, and then what we'll do is we're gonna return this. So let's call this item name here. So we have item dot name. So we get the item, we return its name, and then we also have the item's price. So item price, and then we return the item dot price. Okay, so that looks fine. Let's save this and check our code here, or check this API. Let's refresh this, and then here we see we have our post. We could check that out. Let's try this out. Execute. What do we get? We get in response body item string item price 0. Now if we come here, if we get here, you see a level of this name, and then we put let's say bag, and then price, let's say 20, and then here we execute. What do we get? You see we have bag 20. If there's something you can notice, is the fact that this request body here automatically takes this name and price. So let's get back to the code. You see that if we modify this, let's say we want to get the name, we want to get the price, or let's say we want to get the cost, or let's say we want to get a discount. So let's say this is discount on the item, discount, and then let's put this int. Okay, we save that, and then we get back here, we refresh this, try that out, and you see discount automatically is here. So the role of this schemas is to provide a model which the request body has to always follow. So this means that if you get back here, let's get back here, and let's take one of this off. You see, we take one of them off, we execute check out the response. You see here, expecting property name enclosed in double quotes, all of that. You see here we have this unprocessable entity error. Now this is because here at the level of the request body we didn't specify the discount, which we've already set in the schema that we need to always have. So doing this means that each time anyone has to make a call on this API or on this endpoint right here, that person has to specify the name, the price, and the discount for the request body. Now we could also enforce this kind of measure at the level of the output. So we could specify a response body, and then we define, say, let's say this is input item. Let's call this input item, and then here we would have output item. So we want to create another schema here. Let's copy this, and then we're going to say that, okay, we want this output to be the price minus the discount. So here we have output, and then instead of the price and the discount, we just want the selling price. So here we have selling price, and that will be an integer. Okay, so we have that. Now we have the output, we have the input, and we have the output schemas. They're both subclasses of base model. And then here what we'll do is we'll say, okay, we want to have the selling price. We'll define the selling price to be the item price minus the item discount. Okay, so we have that. So we have this now, and then here we have the item name still, and then we have the item. We have to be careful, the same as this. So we have to say selling price. Anyhow, let's leave that for now. Let's just say we have here selling price. So let's say we have selling price, and then let's save this and check this out. You see already post got an unexpected keyword argument response body. This is actually response model, not response body. So that's the output response model. Let's change this to input. So now this input item for the request, and then this output for the response. Now let's save this. That's fine. Let's go ahead and check this out. So here we try this out. There we go. You see, as usual, that's fine. And then let's give this a price. Let's say 20 and no discount, and then we execute. So what do we get here? Internal server error. Now let's get back to our code and check out what's going on here. Field required, this missing. Now you see that everything looks like normal, but we told that there's a field that's required at the level of the output. And the reason why we have this is simply because this output expects to see selling price. You see, it expects to have selling price. So because we do not have selling price here, we get that error. Now let's save this. We get back here. Let's refresh that, and then try this out again. Execute. No, let's put here 20. Anyway, it should be the same. It's just that we want to have to see the difference in the, or to see how the selling price is computed. Here again we have internal server error. Now this looks funny. Let's get back and see where we get an error. We told field required, and it happens that we even do not specify this correctly. So here is name, price, discount, and this is name. So here we should also have name, so not item name. We save that again. We go ahead and check this out here. Let's refresh that, try this out. Let's just execute, and that's fine. So you see we have that now, and this is because we've put out our outputs correctly. So let's have here, say 200 and then 180, or let's say 20, and then we execute that, and see we have this output. So that's it. We see how thanks to the schemas you could now build APIs which permit the developer or whoever is making use of your API to have to specify this, without which nothing is really going to work. So this means that you could have a situation like here. Let's see, we have this input item, and then let's save that again and get back here. We refresh this page, and then let's try out while taking off this. So we take this one off, and then we go ahead and we execute. You see that the output here 422 is a client error. So this means that the client knows that this error is coming from his or her side. Now we get back here, and then before we move on, we are gonna define this structure or this code structure for our FastAPI projects we'll be working with. So what we want to do is separate the APIs, that's actually the endpoints, from the core. Now when we talk about core, we're talking about, let's get back here, we're talking about carrying out computation like this. So you see this computation, we want to have some separate file which is in charge of doing this. In the case of some deep learning model, we want to have a separate file which will be in charge of say taking the inputs, loading the inputs, passing this input to a model, doing some post-processing, and then from there now the output from that is passed onto this endpoints, because here this is one endpoint and this is another endpoint. So this is like read, this add item. Now getting back here, you see this like having read here, this one endpoint read, this under endpoint add item, this may be under endpoint say update item. So like root, you have get items, post items, and so on and so forth. So now at the level of the core, we want to have our business logic. In our case, for this simple example, our business logic was basically just taking the price and then subtracting the discount. So that was our business logic, but we want to have this in a separate file. Now for the schemas, we want to also have this in some separate files. So we want to have this kind of structure where we have the core, that's the business logic, schemas, and then we have the API in charge of all the different endpoints. Now to do that, we're going to create our service. So from here we're going to add a new folder which we'll call service, and then in the service we're going to add a new file which is basically we'll copy this main into the service here. So we could do this, we could copy that, move that. Now let's stop the server. Okay, we've moved this into our service, and then in the service we have a new folder which we'll call API, and then we'll create another new folder which we'll call the core. Now in this core we have a new folder which we'll call the logic, and we also have another folder which we'll call the schemas. Okay, so we have this this core has this new folder which is called schemas and not the logic. So let's delete this folder here. Let's delete this, move to trash. Okay, so we have that. We have the core which has logic and schemas, and then we have the API now which will have different endpoints. If we now try to launch our server, you see we're getting an error. So what we'll do is we're gonna now, instead of doing main, we're gonna have service.main. So we've created a service directory here, and in here we have our main.py file, and in our main.py file we have our app which we've created. So that's it. Let's save that. Looks fine, and we'll run this and see what we get. You see that works just fine. So now again we could get back here, and then let's refresh that, and then try this out, and this should be successful. You see, that's it. So we could test this out. Let's say we want to have a price of 78 and then 12. We execute, and that's it. Okay, so now we have this little API we've built. Now the next thing we'll be doing will be to clone the YOLOX GitHub repo, and then we will actually install all those different requirements and then test it out, before then integrating this YOLOX into our FastAPI project. That said, we're gonna paste this out here and then go ahead and clone this repo. The repo now cloned, we'll now go ahead and install those different requirements. So let's have this copied out, and then we already have this pip, so let's copy this out and then install the requirements. So let's get back here, paste this out here, and we have this. So in here we have pip install everything, which is in our requirement.txt file. Now, but we have to be careful here, as we have to get into this YOLOX folder. So it's here that you actually have this requirements.txt. So with that, now we're gonna install our requirements. So let's run that. The package is now installed. You could check this out right here. Import torch now works. So we have that, and we could check out the PyTorch version we have already installed. Then to test out our code, we are going to check out this YOLOX right here. Click on the YOLOX, and then we have this demo. We have ONX runtime. Let's copy this here and then paste it out here. Okay, we do not need this readme, we do not need this requirement, we don't need this, we don't need this and this. Okay, the assets too. For this assets, let's copy this one and just put it out here. Okay, we don't need this assets. For data sets, we don't need this folder. The demo, we don't need this anymore. Experiments, we don't need this. This is used for the training. And docs, we don't need this. Tests, we don't need this. Tools, we also don't need this. So let's take this off. Okay, now we're left with this here. We have the weights. We have this YOLOX folder, and then we have our Onyx inference.py file. Now let's exit this here and then test out this code. It's our same command, but now we'll take all this off. We run in this Onyx inference.py file. We specify the weights, we'll specify the image, we'll also specify the threshold and the input shape. So it's similar to what we had already in our Colab notebook. Let's check on this. We've taken this out, so we should have just that. Now running this, you see it runs correct. And if you open this up, you should be able to have this here, but we're not having that because we should create this demo folder. So we have our demo folder. Let's rerun this and see what we get. Okay, click open this. Now and still, let's have this Python 3.8. let's have that, run that, and then check this out. And when we open this up, we see that we have this demo folder which is created. Clicking on this, we have this output exactly as we expected. Now we have the different classes which do not match with what we expect, because in this data, like in this yellow, we have this data sets, Cocoa classes. We need to modify this to match up with what we have here. So let's take all this off and then paste our custom classes. So we have this custom classes. Don't forget to put the top. We have here top, and that should be good. Okay, we have this set. Let's save this. We have that saved, and now we should rerun this and have something giving us the classes we expect to have. Let's reduce this, click on this again, and there we go. You see we have shoe, we go up, we have pants, and then we have shirt, just as we expect. So now we've tested our code out, we could go ahead and integrate this into our API's core section. So in here, we're gonna have this YOLOX code in this logic section right here. Before moving on, we are gonna get rid of this weights folder. Copy this. Let's take this off from here and then paste it out here. So we do not have this weights folder anymore. In this logic folder, we're gonna create a new folder, YOLOX, and then its content now will be basically this YOLOX content here. So we copy that and then also copy the weights. Now let's get back. We have our service, which is made of the API and the core, and the core has logic and schemas. For the logic, we have our YOLOX folder, and then in our YOLOX folder we have this YOLOX directory and our weights, not forgetting the Onyx inference.py file. The Onyx inference.py file has been structured such that we could test out this Onyx object detection model using the command line. Now we need to convert this into a method. So all this here wouldn't be useful anymore. We take all this off, and then we create a method, let's say object detector, and then this method is going to take in an image. So we have this, and then we take this off. Okay, now that said, we do not need this arguments. We have the input shape, which is 416, and then we have this here, which is simply this image. So we have this image. We do not get any, we're not getting the image from the path. The user is going to pass this image. So here we have this image. We now get into the model where we're going to specify the model's path. And so here we have best YOLOX nano.onyx. Okay, now that said, P6 without P6. So we have here false. And then the score threshold, we have here, let's say score threshold, and then here we have score threshold. Now let's define this here. We have score threshold equals, say, 0.1. Okay, so we have the score threshold defined. The next we'll have here is this output directory, which we not need again, so we'll take all this off. And then we have this one, this imWrite. For now, we'll just suppose that we have in this output.jpg, and then we have that, but we'll take this off while finalizing the creation of the API. We'll then move on to create our endpoints. So we get in here, we create this new folder. We'll call it endpoints, and then in this endpoints we have two files. The first is detect.py, and the other one is test.py. So we see that now we could have two different endpoints in these two different files. The role of this detect.py will be for the actual detection, while the role of the test.py will be to see whether the API is even functional. So that's it. Now we could get into this test.py. We're gonna do from FastAPI. We're gonna import API router, and that's it. Now unlike before where we imported FastAPI, now we're using this routing system. So from our main here, we are gonna route information onto this detect.py, and then from here we are gonna then carry out the detection. So instead of app equal FastAPI, now we would have YOLO router equal API router. So we're creating this object of the API router class. Now once we have this set, the next thing will be to have our decorator. We have YOLO router, and then we have this get request where we're going to specify the detect. So here we have detect. So that's it. That said, the next thing we'll do will be to have to define our method. So we have detect, and then in here we're going to take an image, but for let's leave that for now. Let's just return say hello world. So we have this dictionary. For now we're returning hello world. Okay, so that's it. Now what you have to notice here is the fact that unlike before, now we actually going to take in as input an image. And so since we're taking in as input an image, this image we're going to have here will be of type upload file. See, upload file. So here you see this has already been imported. If I do this, take this off, you see once I just have upload file, see that's imported automatically. So you see the importance of having extensions. So that's it, we have upload file, and now we're ready to start playing around with this input image right here. Now let's not forget that the original object detector is in our core. So we'll do from the service.core.logic.onyx inference, we're gonna import our object detector. So we have our object detector there. Now we have that should be okay. We have imported our object detector, and now we're ready to read our file. So here we have im.file.read. We read our file. Then once we read our file, we then use bytes IO module to convert this into bytes. And then from here, once we have this, the next step will be to use this image module to open up this bytes here. So we have this image now, which we get here, and we're gonna store in this image variable. So that's it. So before doing this, we had to import bytes IO. So from this, import bytes IO, and then also we need to import image. So we need to do from pill, we import image. So that's it. We have import images import. The next import will be simply numpy. So numpy as np. Okay, so we have all this imported. The next thing to do will be to convert this image into a numpy array. So we have image here, which is np.array, and that takes in the image. Then what we return here is going to be this object detector method output when it takes in the image. So we have we return object detector, and then it takes in this image. So that's it. So we could now take all this off. So that's how we create this. We have this endpoint right here, which has been created, and here's a path detect. Then before we move on, we are going to check for the file extension. So if we have this image right here, we have the file name, and then we get the file's extension by splitting. So we do the split, and then we grasp the extension. That's the last part of our list. So if we have this in this set of values, or this set of extensions, say GPG, we have JPEG, and then PNG. So if we have this, there we go. If we have this, then in that case we are gonna pass, else we're gonna throw an exception. Now let's get back to this here, handling exceptions. You see, you could raise an HTTP exception and then specify the status code. Now to specify the status code, let's check out this status codes listed out in the mozilla.org site. So here we have 415 unsupported media type. So here we're gonna copy this out. So we raise this exception, this HTTP exception. Let's get back to the code. We have that, we paste this out, and then here we have code 415. Also we have from FastAPI, we're gonna import HTTP exception. Okay, so we have that fine. Now we check for the extension before the file has been uploaded, and then we pass it in our object detector method. Let's then copy out again this here. Let's get back to test and then paste this out. Here we have this is a post request, not a get request. So here we have post. That's fine. And then again, we're gonna copy out some parts of this FastAPI API router. We need this in this test here. So this is to show how you could have different endpoints and then give them each and every one of them a specific file. So it's kind of like a clean way of writing out the code for each and every one of your endpoints. So here we have that. We have our app, which is API router. Anyway, this is API router. We'll take this off, and then this is our test router. We have our test router here, and then here we have test router. So let's call this testing. Okay, we have test router. Fine. So that's it. We just testing. That's fine. So we have this now. We have set this router. Let's get back to our detect.py. We also have this YOLO router. Our next step will be to create an API.py file here. So create API.py file, and this API.py file actually now will contain a router which will then include all these other routers right here. So it's like from this main.py file we get access to this router which we are about to create in this API.py file, and then this router also has this other endpoints included, or this other routers in this endpoints included. So here we have from FastAPI import API router, and then we create a main router. We'll call this main router, and then we have API router. Okay, so we have that object created, and then now we do main router dot include router, and then we're gonna take this router here. So we take the YOLO router and the test router. So we're gonna include this too. We have YOLO router. Anyway, let's import this first. Let's say from service dot API dot endpoints dot detect. We're gonna import the YOLO router, and then from service API endpoints test, we're gonna import the test router. So we have those two. Now we include this YOLO router, and then we also include the test router. So include router, test router, and that's fine. So we've included these two routers here, and we're good to go. So now from the main.py file, we're gonna repeat this same process where we're gonna include now this main router right here. So you look at this way. We have this FastAPI app which is gonna include the main router. So here we're gonna include the main router. Let's change the direction of this arrow. We have this here. This includes the main router, and then the main router on its own part includes the YOLO router and the test router. And then here you could add other endpoints. So you could have some other router added here, and then it's included in this main router. Now getting back to the code, let's have this here. We do app that include router, and then we have the main router. Now here we'll do this import again from service dot API dot endpoints, or no, from service dot API import the main router. Okay, so we have this. We import this main router right here, and then we include it in this app. So now we could access all those different endpoints because we've created this link from our main.py to this API package. Now talking about packages, let's turn all this into packages. So we have this API here. We add a new file, and there we go. Init.py. That's now a package, our API package, endpoints package. We have init.py. There we go. So now we have this packages set for the service. Or let's deal with this core first. So we have the core, and then we have new file init.py, schemas, new file init.py, logic we have in this logic, we have this already, so that's fine. No, not really. We have this init.py is in this here, so let's have this init.py. Okay, so we have that set. Then finally we have this here, new file init.py. Okay, so now we have our service package in this here. Let's check this out. We see everything's okay. Detect. We're still having this problem here. Let's check this out. Core logic, Onyx. No, that is actually in this YOLOX. So this is logic, and then we have YOLOX. So let's have this YOLOX.dat. That's fine. In case this verification for the file name wasn't very clear, let's copy this out and test this out on Collab. So we have this. Let's get back to Collab. There we go. Okay, we have this here. Let's paste this out here. Now let's suppose that our file name, so let's suppose that the file name is equal, for example, testfile.jpg. Now in that case here, you would have this file name. Okay, so let's print this out so you see what we get. Now we print this out first here and then have that. So we print this. You see, it's going to create a list which splits out these two parts. Here's the output we get of this file name which has been split up. Now we see that we could get this element here, this last element, by simply doing this. So we have that, we select the last element, we run this again. You see we have the extension. So now each time we're going to verify if this extension is in this tuple right here. So if the extension isn't in this tuple, then we're going to raise the exception. Else we're going to pass, and then we're going to take the image and then continue with the object detection. Our next step will be to launch the server. So right here we have UVcorn, service domain app, and reload. That's fine. Let's have this here. We get in this error, no model name YOLOX. So let's see from where we get in this error. So it comes from this file here, this Onyx inference file, line 13, sorry, we have that, and then we have this here. So let's do service. So what we're trying to do here is we're trying to make use of this pre-proc method, which is in this data.augment.py file found in the data directory. So we could retrace this from here. Actually, we have YOLOX, we have data, we have data augment, and then we have the you see we have this here. So just right here, let's reduce this. Just in this Onyx inference, what we're gonna have is service. Let's get back here, reduce this so you can see clearly. Yeah, so here we have service dot car dot logic, and we have YOLOX, then we have YOLOX, then and then data augment. So we have this here which we'll copy out and then simply just paste it out right here. Now let's save this. It's gonna reload, and we also have this other error. So here we're gonna get into this data augment. We get into this data augment, and then we check out on line 18. Line 18, we have this. We just paste this out right here. We save that, reload that. We have this same error on the line 10 of the mosaic detection, which is in data sets. So we have this mosaic detection, line 10, we have that. Let's paste this out, and that should be fine. Anyways, just keep making sure we have this replaced, as this YOLOX replaced with this service, or with this path from the service right to the YOLOX. So we just repeat all this process for all the concerned files, and that's it. We've done this for Cocoa Evaluator and VOC Evaluator. Now we have our server running. Let's go ahead and check this out. Docs, there we go. We have detect, we have test, and we have test. We have testing actually. Let's try this out, execute, and see what we get. we're told this is not a valid URL. Let's get back to the code and check out how we define this. We go to the API section, so we see how this makes it easy for us to debug our code. We could get your detect and then simply have this right here. We have that. Let's save this. We get to test and we have this. Save that. That's fine. Main.py, fine. Okay, so we save that and then refresh this page. We get to testing, try out, execute. See, we get testing, that's fine. Test, try out, execute, hello world, that's fine. Now let's get into this post request. So here you see already, because you specified that we needed to do this image of type upload file. Now here you see you need to upload a file. So let's try this out. You see we need to pick a file. Here's the file we're picking, police.jpg. We execute this and what do we get? Internal server error. Let's get back to this here. We can see that the error we get is there is no such file. So here we're gonna make sure we put out this part rightly. So we have service, we have this, let's reduce this so you could see clearly. We have service, core, logic, YOLOX, and then best YOLOX nano Onyx file. So we have that service, core, logic, and YOLOX. Okay, so we have that. Now let's save this and then check this out. Let's get back here and then pick this again and then execute. Having done the error, let's get back. This object has no attribute to list. Okay, let's get to the code here. Now this isn't with the underscore, so this should be like this simply. Let's save this and then see what we get. Execute, and that's it. So you see now that we are able to upload an image and we get the corresponding bounding boxes, their scores, and the different classes. Now we do not want these classes to be outputted with just these numbers, so what we'll do is link this up with the exact class names. So getting back to our onyx.py file, we are going to import the Coco classes. Let's have this services, core, logic, we have YOLOX, the YOLOX, and then in here we have data. So we have data sets, then Coco classes. So we import now the Coco classes. Recall that here we had this Coco classes which we've modified to suit our particular problem. So here we have this Coco classes, and then in our Onyx inference file we've imported it. So there we go, we have that, and now we are going to modify this here. So let's have this classes, let's call this classes list equal the final class indices. So we have here final class indices dot to list, and then what we'll do is we have classes list. We're gonna convert this. So since we have in values like, let's get back to this. We have this here, we have in this list here, right here, let's space this out here. We have in this list, for example, 4949298. okay, we have in this kind of list, and what we're interested in having is instead the corresponding class names and not their indices. So here we're gonna have here we have this indices, here we have this list. Now we're gonna modify this, so we're gonna have the Coco classes. We take in the name, the index. So we have Coco classes index, and then for index in the class list, the classes list actually, let's say for index, for index in the classes list, we're gonna have Coco classes index. So now with this, we are gonna get this exact class names. Like for example, if we're looking for 4, we have 0, 1, 2, 3, 4. Now we save this here and then we execute. So we run that and see what we get. We're getting this internal server error. Let's check out the code, the terminal. Here we told triple indices must be integer or slices not float. So this means that what we're getting here is actually some float, this index here. So we need to convert this to integer before picking out the exact class name. So now let's save this again. We get back here and then execute. Okay, this time around everything works fine. Let's check out our classes. We have pants, shoe, jacket, shoe, and bag. Now also, because we doing this here, we could check out just right here. Let's reduce this. We could check out this output here. We have this output, the JPG file here, which we could check out. You see we have these predictions, but this looks quite slightly different, or quite different from what we had when we were actually running the commands. So this was the output we had when we run the commands. We had a shirt, we had the pants, we had the 2 shoes, but here we having the pants, 2 shoes, but we having jacket and bag, and they're not correctly positioned. So let's try to debug this. One thing we could notice straight away here is this image, although looking similar to the police image we have here, this original image has this blue portions which are highlighted. So let's scroll up. You see the face becomes highlighted. This, we have more of blue at the level of the face as compared to this one, which is the original image. Now this tells us that the input image the model is getting right here isn't exactly what it should get, and so because of that we are going to print out this original image. So let's print this out. We execute this again right here. We have this output. We check on this here on the terminal to see the array which is outputted. Recall that this is going to be a 3-dimensional array as we've seen already in this course. Then from here we are going to get back to that YOLOX code we had cloned from GitHub, which was this original code here, which we had tested already. So right here we're going to create a new terminal. So let's click on plus this. We have this new terminal, and then right here we're going to do cd YOLOX. There we go. But before that we need to get into the venv YOLO virtual environment. So let's get back. We have that. Then now we're gonna have the source, then activate. Okay, so we have this here in this other Onyx inference.py file. We're also gonna print out this original image. Let's have that saved, and then we run this command right here. So we have this command, we run this, and we have this output. Okay, let's increase the size so we could see it better. We have this here. So this is what we have. This is what we get when we run the command, and this is what we get working with our API. This one, the image comes directly from the file we specified here. So we'll specify this file. We read the image using OpenCV, and then the model takes this image and then gives us some outputs. Now we have this here, which is this image right here, but our worry now is we get in 2 different outputs. Like this one here, if you open up demo, you see we have this output. We have this output, which is what we expect, and then when we open up this one from the API, we have something different, coupled with the fact that we have this blue patches everywhere. So let's inspect our image and then see how to resolve that problem. Now here, this is the API here. So we have 247, 220, 209, and then here we have 209, 220, 247. So straight away we notice that there is some swapping which has been done here. Now to better understand the swapping, recall that we have, for example, this kind of image input which could be broken up into the red, green, and blue components. And here each column represents each component. So here we have the red, the green, and the blue. Now with this two, you should also have that red, green, and blue. Now the fact that we have the swapped means that one of this is green, red, blue. So let's get back to this. One of this is rather blue, green, red. So we have something like this. Let's copy this so you understand better what we're trying to say. So we have one of that which is reversed, so the positions are swapped like this. We have this blue, green, red instead. That's why in the middle value is the same. We have the middle values which is still the same here. As you can see, the middle values are all the same. Here we have middle values the same, but the side values are swapped. So getting back here, you see that we have something like this. And then what we can do now to say leave from this here to get from this, let's take this, to get from this BGR, that's blue, green, red, to this red, green, blue, RGB, we are going to make use of OpenCV's CVT color method, which takes in an image, and then if that image is BGR, that's blue, green, red, it converts it to RGB. So we have this here, we pass in this parameter, and then our image now becomes this. So let's have this, and then let's save that. Let's go ahead and run this with FastAPI again. Let's have this, let's execute. Now note the answers we have here. We have all the classes. We have pants, shoe, jacket, shoe, bag. Now when we run this now, you see we have pants, shoe, jacket, shoe, bag again. Now checking back at the code is because we didn't put this at the right position. We should have this just before here. So this is the image value is changed before it gets into this origin image here. So let's save this, get back, re-execute, and you see that we have the right responses. Now we have pants, shirt, shoe, shoe. Now we have that set. Let's get back to the code, and then here we look at our output. We see now that our output is exactly what we have here. So we have the exact same output with what we had in the demo. And then also if we inspect this here, you see 247, 220, 209, and here we have 209. This is quite different. Let's get back here, scroll down. This is a previous output. Let's go up 209. Okay, so here we have 209, 220, 247, 209, 220, 247. So now we have R, G, and B, same as this. From this point, we're gonna get into our schemas. So with the schemas, as we said before, we'll be able to validate our input and output data. We have here schemas. Let's create a new file. We have input.py, and then we have output.py. Now with this here, we'll start by importing the base model. So from Pydantic, we import the base model. That's it. Then from here we have our API output class. We'll call this API output class, inherits from base model, and then we'll define this different attributes which we want our outputs to have. We have boxes, which is a list. We have classes. This one too is a list, and then finally we have scores. We have scores, list. We have classes now, also a list. Then we are gonna link this up with our detect.py right here. So we have this. Now here we specify we want a response model. Our response model. Now this response model here simply means we are going to validate our output before it has been sent. So we have the response model API output. We are going to import that. So we have from services, we have the core schemas output. We're going to import the API output. We already had it here. Okay, we have that. So we have this, and then from here now we are going to test this API out. So let's save this and then get back here, click execute, and we have this output. Now what if we have this output which is different from what we expect? So what if, let's get back into this Onyx, or let's start by taking this output. Let's say final output is equal this here. We have this, take this off, paste it out here. We have our final output, which is this, and then we want to return the boxes, the scores, and the classes. We could test this out. This should work just fine. Execute. That's fine. Okay, so let's suppose that we do not return the classes. So let's have that off and then test this out. This seems to work surprisingly. Let's check back at the code. Now let's get back here. We made an error here. This isn't at this position. We are not passing this in the detect method. This is being passed in here. It's been passing this post method here instead of this detect method. So let's have that. We save it again and then go ahead and test our API. You see, now we have internal server error, and this is simply because the data has not been properly validated. And to correct this, we just have to do classes, final output, and then we have the classes. So once we have this, let's go ahead, execute. You see, now everything works fine, and this is because there's a matching between the output and the expected output. So we define all this in here. Now since our input is just the image, we're not going to have any validation. We're just going to leave it that way. We have this image here, which is of type upload file, so we have that passed in, and then it goes through this object detector method to produce this different outputs. We're also going to take this off, so let's comment this part. And then now let's look at the timing. So let's suppose that we have this here. We get the image, and then we pass this into our model. So from the time we get the image and want to pre-process, we can define this time right here. Tinit time.time. Let's not forget to import time. So just right here, let's do import time. That's fine. Tinit equal time.time, and then here we're gonna measure the time elapsed after we get the output. So we have here time elapsed equal time.time. So the current time minus the initial time init. So that's it. Okay, we have this time init has been defined already. This should be, oh okay, that's t init. So we have that t init, and then now let's have this here time elapsed, and then we have simply the time elapsed. So we have here time elapsed. Okay, so we have that set, and let's save this now. Then we go ahead and include this in our schemas. We have your logic, schemas, output. Let's include the time elapsed. We have time elapsed, and then this is a string. So here we have a string. Okay, we have that. We save that, and then go ahead and run this here. Internal server error, which is happening because at the level of this detect right here, we didn't include the time elapsed. So let's have this time elapsed included. Time elapsed, final output, and then have that time elapsed. Okay, so let's have that. We save this and then retry this execution. We see we have it now work fine. You have that, so on and so forth. So here you could, let's increase this. So here you could see the time it takes. It takes 102 milliseconds, and you have this here. So you have your boxes, you have your scores, and you have your classes. In order to reduce the time taken for the model to ingest the input and then produce the outputs, what we're gonna do is we're gonna load this session on server startup. So let's take this off from here. We get back to our main.py and then have this. So right here we're gonna have this session. Let's import Onyx runtime. There we go. Save that. We get back to the Onyx inference.py file. Let's import service.main as s. So here we have s.session, and then we also have s.session right here. Let's save that. That's fine. We get back here, execute, and see what we get. You see that now we have a time elapsed of about 36 milliseconds, which is a drop from the 102 milliseconds we had previously. And this is simply because we now load the model in this main.py, and then now each time we want to make use of the model, we now just run the model without having to preload it in this object detector method. One great advantage of working with a FastAPI framework is the fact that our code can be run asynchronously. So let's get back to our endpoints here. All we need to do to enable this asynchronous behavior is adding the keyword async before the def keyword. So once we have that, that's fine. Here we will do the same. We just need to put async, and that's good. So we get here too. No, that's in the main. In the main, we also have this, and we have that. And so this means that when working with FastAPI, if we have this task, for example, this one which takes much time to be completed, what goes on is these other tasks can be run asynchronously. And so while waiting for this task, for example, let's do it here. While waiting for this task, we could already start working on this other task. And then while waiting for this other task to be completed, we could also start working on some other tasks. This means that overall, we have taken up this time to complete these 3 tasks, whereas for synchronous code, we'll have to wait for each and every task to be completed before taking on the next one. So you see the time difference between these 2 different methods. We have here the difference. We see this difference here. So this is our gain in time when working with FastAPI's asynchronous manner of running code. Nonetheless, it should be noted that there are some tasks which are compute bound. They're actually CPU bound, meaning that even if you have to run this code asynchronously, this first task will still take up so much time. So you would end up with something like this. So there will be no real gain, even though you had to run this other tasks asynchronously. And this is very common in computer vision. And since we're dealing with computer vision, more specifically object detection, we have to understand that even though our code is running asynchronously, if we have let's get back to the code. If we have this call right here, if we have this call, for example, on this object detector method, and this object detection method is yet to produce the output, no matter that we've already completed these 2 tasks right here, we'll still have to wait for this object detector to be complete. So for such CPU bound tasks like computer vision, machine learning, deep learning, we'll instead take advantage of parallelism. With parallelism, instead of having one CPU worker to run all these different tasks, what we could do is we could allocate, say, for example, let's say 3 workers. So we have now 3 workers where each worker can focus on a given task. And now we can now take advantage of the fact that our code runs asynchronously and takes or makes use of parallelism. Now, so far, we've been using this UVCon HTTP server, which is an ASGI web server implementation for Python. ASGI actually means Asynchronous Server Gateway Interface, which now serves as a minimal low-level server interface for an async framework like FastAPI. Now, although UVCon is coming with speed, it isn't mature enough to be used in the production setting. Hence, we tend to use Gunicon, which is a mature, fully featured server and process manager for our production settings. So that's why UVCon includes a Gunicon worker class, allowing you to run ASGI applications with all of UVCon's performance benefits, while also giving you Gunicon's fully featured process management. And so we'll get back right here and do pip install Gunicon. Gunicon now installed. We are going to run this server. Gunicon now installed. We are going to start our server with Gunicon. Here we have this number of workers, let's increase this. Let's take 3 workers, or let's say 2 workers. We have that, and the worker class UVcorn, as we had seen already in the UVcorn documentation right here. So there we go. Let's run this and see what we get. Notice here how we have this booting worker with PID with this number, booting worker with PID with this. And so you see that we have this 2 workers, hence the reason why we have this booting worker with PID appearing twice. Now if we scroll up to when we were using this UVcorn, so let's get back up. We had some errors here, so let's get back to the top. What we could do is let's stop this and then just get back to using just UVcorn. Let's run this and see what we get. You see here you have started server process, and this ID is given. This appears just once, and then when you scroll up here, you see you have with this booting worker, you also have the started server process. This appears with this ID, and then this other started server process with this other ID, because now we have 2 workers. Let's scroll down again. Let's stop this. Gunicorn, let's increase the number of workers. Oops, we have Gunicorn. Take this off, 3, run that, and you see we have this boolean which appears twice. We have started server, started server, started server process. Okay, so we have that. Now let's get to this page. Docs, there we go. Detect, try this out. We browse, police, select, execute, and see what we get. So let's execute that again. You see these are the values now. This is the time taken now to run this object detection code. Verify, we still have the same outputs, which is normal. Okay, so we have that. You could always, and one other thing we can do is to test our API from Postman. So right here, let's have this. Let's have, we have 127 our local host 8000, and then that's it. We have API and then detect. Okay, we have that. We select the method type post, the body, form data, the key. Let's reduce this, the key, the value. It's actually it's a file, so we should have this here. We select police, and then we send. So let's see what we get. Detail not found. Let's get back to the documentation right here. We have this. Okay, yes, detect, no API. So let's copy this and then paste it out here. We have that. Run that again, and this is what we get. So you see that even from Postman, we're able to access our API and get this different outputs. So we see we have exact same outputs as expected. And with this, we've just completed the section where we've built our own object detection API, and now we're set to deploy this API on the cloud.